In this session, let us see about the general rules for C programming and the primitive data types used in C. Every executable statement in a C program must end up with a semicolon, and every C program must contain exactly one main method, which indicates the starting line of the program. And all the system-defined words, which are called as the keywords, must be used in a lowercase letter. And keywords cannot be used as an user-defined names, which we call it as the identifiers. And for every open brace, there must be a respective closing brace, and every variable must be declared before it is being used. So these are some of the rules for any C program. And now let us see about the identifiers. So identifiers allows us to name the data and other objects in a program. And some of the rules for identifier is every identifier in a C program must start with an alphabetic character or a digit or an underscore. And it cannot be same as a keyword. So let us see an example of an valid and an invalid identifier. So student underscore name is a valid identifier. Whereas when we look into names, here we see that the identifiers start with a numeric, which is not allowed. And keywords are the system-defined identifiers in C programming. So there are about 32 keywords in C programming, and some of the 32 keywords are being listed in the table here. Say auto, break, case, char, const, continue, default, do, if, for, all those are called as the keywords in C programming. And they have a specific meaning in the language, and they cannot be used by the programmer as the variable name or the constant name. And let us see what is meant by variables in C. So these variables are the name memory locations that have a type such as integer or character, which is inherited from their type. And this type will determine the value that the variable may contain and the operations that can be used with its value. So say for example, we have a snippet code here. So this char code is called as the identifier, and this identifier is of the data type character. And here int I is the variable identifier, and this type of the variable identifier is the integer. And this is how the variables are being represented in the memory. So code is the identifier, and this code can hold a character value. And I is an integer data type, and it can hold an integer value in the memory. And next, let us see what is meant by constants in C. So these constants are the data values that cannot be changed during the execution of a program. Say that we have the constant value for pi as 3.14. So we can define as const double pi is equal to 3.14. So the value of pi cannot be changed during the entire execution of the program. And there are different types of constants: integer constant, floating point constant, character constant, and string constants. The integer constant is a numeric constant without any fractional or exponential part. And there are three types of integer constants in C programming, which can have a decimal constant or an octal constant and an hexadecimal constant with a base of 10, 8, and 16. And next is a floating point constant. In floating point constant, it can have either a fractional form or an exponential form. A character constant is a constant which uses a single quotation around the characters. And string constant can be represented with a pair of double quotes. And some of the escape sequences that is used in C programming are /b for backspace, /f for form feed, /n for new line, and so on. So here, this /n will indicate the new line, and let us see an example with the escape sequence /n. Say that this is a small snippet. So here, within the main function, I'm supposed to print I'm unstoppable. So I want I'm on the first line and unstoppable on the next line. So how can I do this is, so I can give a escape sequence /n between I'm and unstoppable, which will move the cursor to the beginning of the next line. So this is how my output is going to be. And now let us see about the primitive data types which is used in C. So every variable in C has an associated data type. So it specifies the type of data that the variable can store, like integer, character, floating, double, and so on. So every data type will require different amount of memory and has some specific operations which can be performed over it. So first data type is the integer data type. So in an integer data type, it is used to store the whole number without a decimal value. Even we can store an octal value or a hexadecimal value in the integer data type. So the range for the integer data type in C is determined by the number of bits which is allocated for storing the integer and whether the number is unsigned or an unsigned number. So for an unsigned integer, say that the number of bits that will be allocated is 32 bits. So one is the signed bit and the rest of the 31 bits are called as the value bits. And the range for a 32-bit signed integer is calculated for the negative range as -2 to the power of 31 to -1, and the positive range for a 32-bit signed integer ranges from 0 to 2 to the power of 31 minus 1. If it is an unsigned integer, then we are supposed to eliminate the sign bit, and if as it does not contain the sign bit, the range will be from 0 to 2 to the power of 32 minus 1. So here are the different types of integer types. So we have different types such as short int, long int, and long int. And the number of bytes which is occupied by the short int is 2, for integer it is 4, for long int it is 4, and for long int it is 8. And the size of short integer is lesser than the size of the integer, and which is lesser than the size of long, and it is still lesser than the size of long. And next is the floating point data type. So this floating point data type is used to store the decimal and the exponential value. And the range of the floating point data type in C is determined by its representation, which adheres to the IEEE 754 standard. So the most common floating point data type in C is float and double. And the format specifier for this floating point data type is %f. And there are different types of floating point types. It is float, double, and long. And coming to void data type, it does not have any value and no operation is performed. It is used to represent nothing. And this void is used in multiple ways as function return type and the function argument as void. And next is about the size of data type in C. So the size of the data type in C is dependent upon the size of the architecture. So we cannot define the universal size of a data type. So for that, C language provides the size of operator to check out the data types. So now let us see with an example. So here, if I have to check out for the size of the integer, character, float, double, then I can use the size of operator to perform it. So I'm just initializing the variable size of int, which is an integer data type, and I'm just calling the function called size of int. And now when the size of operator is used, it will return the size of integer value and it will be printed in the printf statement. So the output of the integer data type is 4. The size of the integer data type is 4. And the output for the character data type is 1. And the size of the floating point data type is 4. And the size of the double data type is 8.